Now, in this video, we will going to discuss about the projections of lines. One more problem on projections of lines. So the problem is given like this. A line capital AB 60 mm long has one of its extremities 20 mm in front of VP and 15 mm above HP. The line is inclined at 25 degrees to HP and 40 degrees to VP. Draw its top and front views. So here our main intention is to find the top and front views. Now we need to analyze this problem, how we can solve this problem. A line capital AB 60 mm long. Since it is capital AB, obviously it should be in true length. So what is the condition for the line to be in true length? If the true length of the line is in the vertical plane, then the line is parallel to VP. If the true length is in the horizontal plane, then the line is parallel to HP. So that is the condition. Has one of its extremities, has one of its end point. End point of the line capital AB, one of its end points. It can be either A or it can be B, but we will going to take it as A. One of its extremities is 20 mm in front of VP and 15 mm above HP. When you look from the front view, we can see the distance above HP by 15 mm. And when it is projected, that projection will going to fall on the vertical plane. So we will going to get it as small a dash. Similarly, 20 mm in front of VP, in front of VP distance, that is from here to here. So this distance is in front of VP. When you look from the top view, that distance is projected directly onto the horizontal plane. So we will going to get this point. The distance from here to here is 20 mm. So since the distance of the point A is given, so 15 mm above HP and 20 mm in front of VP, so you will going to fix the point capital A. Then you are going to fix the point as small a and a dash, both in the top and front view respectively. The line is inclined at 25 degrees to HP. So the line means the true length of the line is inclined at 25 degrees to HP. So the inclination with respect to HP is seen in the vertical plane. So with A as center, you measure a distance of 60 mm, which is inclined at 25 degrees to HP, and draw an inclined line so that you will going to get capital A B1. So when you look from the front view, we can see that the image will going to fall directly on the vertical plane. So you're going to get this point A dash and B1 dash. The length of this capital AB1 will going to be the same as A dash B1 dash, which is 60 mm, and the line is inclined at 25 degrees to HP. Why? Because that is the parallel to VP, because A is in front of VP by 20 mm. Therefore, B1 is also in front of VP by 20 mm. So now the line is parallel to VP. Since the line is parallel to VP, we are getting the true length in VP, which is A dash B1 dash. So now once you get the B1 dash in the front view, so you know that the front view line of the point B dash should lie on this particular line. So therefore we are going to call this as locus of B in the front view. Similarly, when this line is, when you look from the top view, A is projected already, which is 20 mm in front of VP, and this capital B1 is also in front of VP by 20 mm. Therefore, when you look from the top view, you will going to get it as small AB1, which is here. So we got this particular top view now. So that means you can see that in this particular sketch, we will be able to get this. So that means we are getting that 60 mm. So when it is projected, you will going to get this small AB1, which will going to be the top view for this front view line A dash B1 dash. So capital AB1 is the one which is the line which is in space. So when you look from the top view, A is in front of EP by 20 mm and B1 is also in front of EP by 20 mm. Therefore, AB1 is parallel to VP. Since the AB1 is parallel to VP, therefore A dash B1 dash is in true length. So now we got the locus. Now we will going to get back to this now again. So when you look from the top view, we will going to say the line is inclined at 40 degrees to VP. The inclination with respect to VP seen in HP. Since I want to see the image in HP, therefore I should look from a view which is perpendicular to that plane. So that means when you look from the top view, capital AB2 is the line which is having a length of 60 mm and inclined at 40 degrees to VP. So you are going to get this capital AB1. You know that it is the true length in HP because A is above HP by 15 mm and B2 is also above HP by 15 mm. Therefore, capital AB2 is the line which is in true length. Since the line is parallel to HP, so we are getting the true length in HP. So you're going to get this as AB2. So we will going to get, when you look from the front view, that the image is projected directly A is to A dash and B2 is projected till to A dash B2 dash. This is also quite evident from this particular view when you are considering this AB2 which is parallel to HP. So when you look from the front view, we can see that A dash B2 dash is the line which is parallel to HP. Since this line is parallel to HP, therefore you are getting the true length in HP. Once you get the point B2, so you will automatically, we will going to get the locus of B in the top view. Once you get the locus of B in the both front and top view, it is very easy to write the front and top views. So how to write the front and top views? Now to do that, we will come back to this now. So actually now we have now the position is, suppose if I consider from the front view. So what I want to write the top view now. To write the top view, I have to consider the true length. We know that this line capital AB1 is in true length. Why? Because that line is parallel to VP. So we can see here capital small AB1 is the line which is parallel to XY. In the top view, the line is parallel. Then corresponding front view will be in true length. So A dash B1 dash is in true length. So you have the locus of B. But the top view of A dash B1 dash is AB1. But due to the presence of the locus of B in the top view, therefore, then what happens? The point B1 will not be here. So the point B1 should lie on the locus of B. So since point B1 should lie on the locus of B, with A as center, AB1 as the radius, you rotate such that this B1 will going to touch us the locus of B in the top view. So you can see here, I have been seeing that through the mouse. You can see that AB1 will going to be rotated such that it will going to touch the locus of B in the top view. Since we are rotating in space, what happens? As we are looking from the top view, the image, corresponding image will also be get rotated. So with A as center, AB1 as the radius, it rotates such that it will going to touch us the locus of B in the top view. So when you look from the top view, since it is capital B, so you will going to get it as small b, which will going to cut the locus. Then join A to B with a dark line. So now we got the top view. How I can show that? We can show that here with A dash. Now this is the true length in the vertical plane. If this is the true length in the vertical plane, obviously that should be, the top view line should be parallel. When you look from the top view, that is A dash B1 dash. So the top view of A dash B1 dash is AB1. So it should be parallel to XY. We know the distance of point A is 20 mm in front of VP because it is given in the problem. So AB1 should be parallel to XY. So B1 should also be in front of VP by 20 mm, then only that line is parallel to XY. So for you are projecting from B1 dash straight away to this locus of A, then but actually the locus of B is on the top view is here with A as center, taking the radius of AB1. You rotate it such that it will going to cut the locus of B in the top view. So you're going to mark this point as B, then join A to B with a dark line. So this is what we have done. Now again we will go back to this. Now we need to consider the front view. I want to write the front view. Exactly the same way what we did for the top view, we have to do the same thing. How to do that? So now we know that we have to take the true length in the top view. So how to consider the true length in the top view? We know that this is the true length in HP because capital AB2 is parallel to HP. How do I know? When you look from the front view, we can decide that A dash B2 dash is the line which is parallel to HP. While A dash is above HP by 15 mm, B2 dash should also be above HP by 15 mm. Therefore, A dash B2 dash is parallel to XY or parallel to HP. Since A dash B2 dash is parallel to HP, therefore its corresponding top view will be in true length. That means AB2 should be the line which will be in true length. So you can say AB2 is the one which will be in true length. Now what I want to do, I want to find out the front view. With A as center taking the radius of AB2, you rotate such that B2 will going to touches the locus of B in the front view. So when you project this point, so automatically that will comes and touches this point B dash. So that means A dash is center. So once you rotate in space, when you look from the top view, that image will going to touches the locus of B in the top view, in the front view, so that you will going to get this point B dash. Then join A dash B dash with a dark line. So this will going to be the inclination of the apparent inclination with respect to HP, which is called alpha. And the inclination, apparent inclination with respect to VP is called beta. So the same thing which will going to be explained here separately. So what we can do is now we need to write the front view. To write the front view, we have to take the top view true length. So which is the top view true length? AB2 is the top view true length. So we have AB2 which is the top view true length. Once you want to find, so what is the top front view of this AB2? The front view of this AB2 is A dash B2 dash. So this A dash is above HP by 15 mm and B2 dash should also be above HP by 15 mm. But due to the presence of locus of B in the front view, so with A as center, taking the radius of AB2, you rotate it such that the image, what you see when you look from the front view, that B2 dash is also rotated such that it will going to touch us the locus of B in the front view. That means this line is rotated like this so that the image will going to comes and touches this point. When it is projected from B, it will going to touch us the B dash. So you will going to get the locus of B here. Then join A dash B dash. So join A dash B dash. So this is how, and the inclination made by the apparent, the inclination made by front view with respect to HP is called alpha. So this is how we will be able to analyze this. Now when you go back to this, here we draw the XY line and you mark HP and VP. So we will going to solve this problem manually. So how to do that? So once you draw XY and you mark VP and HP, so you measure the distance of 15 mm above HP in VP and 20 mm in front of VP is in HP. So you consider any point and you mark this point. You mark this as A dash and A. With A as center, taking the radius of, taking the inclination of 40 degrees to VP, which is in HP. So you measure 40 degrees and draw a inclined line. Similarly, with A dash as center, taking the measuring the inclination of 25 degree, you draw one more inclined line because 25 degrees to HP is seen in VP since VP is above XY line. By using the compass, you measure a distance of 60 mm, cut it on 25 degree line and also on 40 degree line. because the true inclination is same, the true length is same both in the front view and as well as in the top view. So once you get this and you mark this point as B1 dash in the front view and B2 in the top view and join AB2 and A dash B1 dash. Since these two lines are true length, so you mark this as capital A and capital B, and you mark in the top view also capital A and capital B. So since we are marking this as capital A and capital B, therefore the true length is same both in the front view and as well as in the top view. Once you get this B1 dash in the front view, so you draw a dash dot line so that you will going to get the locus of B. Similarly, once you get B2, so you know the locus of B in the top view. Our main intention is to find out the locuses in both front view and the top view. That is our main intention. So we know that this is the true length in the vertical plane. Obviously, that should be parallel to XY line in the top view. So A dash B1 dash is there, but we don't have the top view of AB1. So A is in front of VP by 20 mm. So B1 should also be in front of VP by 20 mm. Therefore, you project from B1 dash directly onto the locus of A, such that both AB1 will be in front of VP by 20 mm. Due to the presence of locus of B in the top view, with A as center, taking the radius of AB1, you rotate it such that it will going to cut the locus of B in the top view. So you mark this point as small b and join A to B with a dark line. Similarly, now we need to find out the true length find out the front view. To find out the front view, I need to take the top view true length. We know that this is capital A and this is capital B in the top view, so obviously this will going to be in the true length. But if you tell it has to be a true length in the top view, obviously that should be parallel to HP in the front view. That means A dash is above HP by 15 mm, B2 dash should also be above HP by 15 mm. So from B2 you draw a vertical projector so that it will going to touch the locus of B, locus of A in the front view. So A dash and B2 dash both are above HP by 15 mm. But due to the presence of locus of B in the front view, which is above HP by some distance, with A dash as center, with A dash B2 dash as the radius, you draw an arc such that it will going to touch the locus of B in the front view, and you mark this point as B dash and join A dash B dash with a dark line. So we need to write just the top and front views. So we have written the top and front views and show the dimensions as per the drawing shown. So this is how we can be able to analyze this problem when the true length is given and also the inclination with respect to both HP and VP is given. So this is how we can be able to analyze the problem. Thank you.